Hey, thank you guys for joining us today. So we're gonna get started here. So my name is Misha, this is Jimmy, and this is Nate, and we're on the Windows Defender and OS security teams, and today we're gonna be talking about Windows Defender Exploit Guard. So kind of the agenda for the day is we want to tell you about this new feature that we're releasing in October in the Fall Creators Update, and the 4 different capabilities that it has within it: attack surface reduction, controlled folder access, network protection, and exploit protection. We want to there we go. We want to show you guys some demos about that, and then also kind of give you the takeaway that this is a new set of intrusion prevention tools to keep your company safe. We will tell you about how you can protect against macro, email, and script-based threats. You can prevent data from access by untrusted processes. You can stop web-based threats by blocking the outbound connection. And you can reduce the exploitability of your system and applications with built-in Emmet-like memory mitigations. So to start off a little bit of just kind of the Windows 10 security landscape. So we kind of have a bunch of capabilities on pre-breach and post-breach, device protection, threat resistance, identity protection, information protection, and then kind of post-breach investigation and response. So looking into the threat protection resistance, where kind of Windows Defender specializes on. So kind of with off-machine capabilities, it's like you have Office 365, you have a bunch of hardening and prevention and edge. We kind of have a bunch of capabilities to lock down the device itself with Windows 10s, Credential Guard, Device Guard. And then we also have application control to help you whitelist your applications. And then also App Guard for kind of app isolation. Then we kind of have Windows Defender Exploit Guard, which in its 4 different capabilities. We have our Windows Defender antivirus to kind of help protect the machine from, with machine learning and heuristic-based protections and exploits. And then kind of once we start moving into the post-breach category, we have a lot of capabilities on the Windows Defender side for kind of a behavioral analysis of different threats after the fact. We have kind of the Windows Defender ATP, which is, I'm sure you've seen some demos of that, kind of this console for going and viewing and investigating all of these different attacks and what's going and actually being able to respond from that. And then off machine, there's also some built-in ties with OneDrive to kind of help you go and remediate that. And the area that we're going to be focusing on is Windows Defender Exploit Guard, which is this intrusion prevention set of capabilities. And within it, there's these 4 areas: attack surface reduction, which is a set of rules to customize the attack surface of your device. There's controlled folder access, which is a setting you can turn on to protect your data from unauthorized access by untrusted processes. Exploit protection, which is this memory mitigation, mitigations against memory-based, return-oriented programming type attacks. And network protection, where we can actually block the outbound traffic to untrusted sources from all processes and all outbound calls on the device. So why Windows Defender Exploit Guard? And it kind of fits into this 3-part strategy, where first you want to actually block attacks at the front line. And you really just make it more difficult for attackers to compromise your entry points. And those are the things that you want to go lock down. Then we kind of actually want to go in and have defenses to minimize damage. We assume that these frontline defenses are going to fail. It's almost inevitable. And when that happens, we want to make it more difficult to cause damage from the environment to spread and actually prevent lateral movement. And then we also have some recovery and response, which is assume everything's going to fail. And at that point, we want to be able to respond to these threats, detect them, disrupt attacks, and then also be able to get back to a good state and recover any damage that we might have caused. So this kind of leads us to like, how do we actually go and secure apps and devices with Exploit Guard? So the first thing that we really want to try and do is just have a bunch of controls to go and minimize the attack surface. And we want to do this kind of in a signatureless way, where we go and be able to find those entry vectors for malware, lock them down kind of based on this cloud intelligence, and prevent malware from actually getting on and executing on the machine in the first place. We also want to go and be up to date with the latest and greatest exploitation techniques that are out there and break them and prevent them from going and executing. And we kind of have this capability within Microsoft because we have a world-class research team, and they're staying up to date, tracking what's the most recent malware doing, what exploits is it taking, and then also building in these securities both into the device and now in this component exploit protection that allows you to go and customize these settings. Then the third part that we're targeting with Exploit Guard is to actually contain damage and prevent persistence. We know your folders, your processes, your data assets are important to you, and we want to protect them from access by undetected malware and unknown threats, things that we haven't seen before, trying to access your data, your processes, your applications. We want to protect that. And then the last part here is we also want to limit the window of exposure to threats. We want to have the capability to be able to respond reactively when things come up to emerging exploits or threats, and actually go and turn on these mitigations or set some of these controls. So here we're going to go dive into this first component, which is attack surface reduction. And to do that, we're first going to talk a little bit about email-borne ransomware, which is kind of a profitable model for malware to monetize its attacks. It generally targets the end user. Attackers can rapidly scale and send out more and more of these kinds of attacks just once they find out that they can make money doing that. And then it's also an anonymous channel through Bitcoin. So I'm going to dive into a little bit on how these attacks works and how ExploitGuard and the attack surface reduction capability can go and actually mitigate this. So the general pattern is we receive a malicious email, and they send these emails out in all various kinds of forms to all these different endpoints that you have. And it takes a user to open a mail. And there we kind of have a Word document, a PowerShell, a zip, a JS, a VB script. And all of those contain some malicious code or exploit that the user kind of opens it, ignores the warning, and clicks yes. This has happened to any one of us. Just go click on this file, open it. And then it either runs directly onto the machine because it has the exploit built in, or once it does that, it goes, talks home to its command and control center, downloads a much more malicious payload, and then goes and actually starts encrypting the device. And when that happens, you're toast. So for that, it's really just you get an email, click on the wrong thing, and then your whole machine is compromised. And so before I kind of continue here, I want to go swap and demo a little bit like what this actually looks like. Because we're going to be using this example for kind of some of the other demos here. Sweet. So kind of this is me with this is my Outlook account, I got a phishing mail. It says, hey, your account has a debt, it's past due, or you owe us some money, please see these attached documents with information on your case and how to pay. So that sounds pretty reasonable. I'm going to go and actually download this file. And we see down here that as this thing downloads, that I'm going to go save this. And antivirus runs a security scan. There's nothing innocuous that's happening here, just a Word file with some macros in it. And I'm going to open this folder, and I'm actually going to go and open this open this Word file. And before I do that, I want to show you one thing, which is the C/demos folder that I have here. And this is this folder that has my important photos, my important data. So if I go and actually click into this thing, we'll see that sensitive HBI data, information that you don't want anyone to have access to or you don't want to lose it. And so here we're going to go open this Word file. And as I do that, I'm also going to go and download one other file here too, which is I got some other email that says, hey, get my tax rebate, gives me some zip file. I'm going to go and actually download this file as well. So as I save this, so let's go. So this Word file here is ready to go. And here it says kind of warning. It's some scary text, but it could also just have something that's tricking you into going to clicking it. And so all I have to do is actually go and enable the content. And what it's going to do is it has a ransomware sample embedded inside of it. And it drops that and actually pops up this scary web page, says, hey, your files are encrypted. Follow some instructions to decrypt this and pay us Bitcoins. Sounds pretty menacing. So let's go take a look at this demo folder that we have here. And now we see that all it took was to click this one Word file. My stuff's encrypted. It dropped these instructions. And then now if we go take a look at this data file that we have, it's garbage. And so that's not something that we want at all. And so luckily, I kind of have the ability to reset that. So I'm going to run that real quick and show you the other example that we did, which was we had a zip file. And it kind of has the same example, has some script inside of it. We go, run this, and same thing happens. It goes, drops this same ransomware sample, compromises our network, or compromises our data and assets. And these can come from email, can come from USB, all these different channels through which these files can actually get onto your machine. So now as we swap back to the primary machine here, so we saw there that there was an Office file. And as kind of security people were thinking, how do we not have that happen to us? And kind of the first thing that you think is like, okay, can I just block all Office files from my enterprise? And in reality, that's going to be pretty challenging because we're presenting off of Office files. We use them for productivity all of the time. And so then you start diving in and saying, what about Office files is malicious? Can I block any Office file that has some macro file? And definitely not. There's a ton of productivity-related macros that we all use, kind of our finance departments, HR, full of macros. And then we start diving into what about these are actually malicious. Is it the ones that go and execute content? That's a behavior that's much more aligned with something malicious, but there's still some kind of productivity use cases there. And then we start diving even deeper, which is these files that download and execute content, for example. That's almost exclusively a pattern of malicious malware and something that we don't really want anybody to, we don't want to have any macros that go and execute these behaviors. And so these are the smart controls that are provided within Windows Defender Exploit Guard. You can go and lock down a particular behavior like that from this email-facing vector. So the intelligent attack surface reduction rules that we have three different categories. We have Office rules, we have script-based rules, and then we have an email rule. And so all of these rules are kind of powered in the back end with all this intelligence that we have. It goes and it's shipped down into the client, and it doesn't require an internet connection to run. And whenever these patterns are exhibited, it goes and actually blocks them. So with Office, we kind of have these 4 different capabilities we can block Office apps from creating executable content. But while that happens, it's not going to prevent updates from running. We block Office apps from creating child processes or from injecting into other processes. Or we can block these Win32 imports from being used, which are kind of all patterns that malware uses in macro files to go and compromise your machine. Then for script-based rules, you have the capability to go and turn on the capability to block obfuscated JavaScript, VB script, PowerShell, or macro code from running. So any macro or script that has obfuscated content inside of it can get blocked. And then we also can block these JavaScript and VB script from executing payloads that are downloaded from the internet. And then lastly, the email rules. We can actually block the execution of executable content that gets dropped from email, which is either from webmail or from different mail clients. So kind of to block that vector from getting onto the machine. And so the flow, and so I'm going to talk about the next couple of things are true for all of the different exploit guard features that we have. And so we kind of have this case where like you are proactive. You're like, oh, there's some threat that's out there. I read on Twitter that this is something that I might need to turn on. So you go and enable any of these rules in audit mode, which gives you optics into what's going on without actually executing the block. So you turn this on, you either do that proactively or reactively. Something happened, there's a threat that you're reading about, you're compromised on your network, and you don't want that to happen in the future, so you turn it on. And then you actually get visibility into what are these behaviors being exhibited on my enterprise. And so then you can go and actually review the impact of this. You're seeing, is there execution? Are some of my macros in creating these child processes? And then you can actually go and convert these rules into block mode or enforcement mode, where if any of these patterns that you've turned on are exhibited, it goes and blocks and prevents the execution. And then all of the different exploit guard capabilities are easily manageable. They all have GP and MDM support. So you can use your favorite Intune or SSCM cloud manager to actually go and configure all of these settings however you want to, deploy them to whatever machines you want. And then finally, this is all integrated with the ATP console and the Windows Defender Security Center online. And so all of the events that are exhibited here go and flow into that. So you can actually go and review across all the different endpoints and take action on these results that are being surfaced up. And you can actually kind of dig in and see what about these different behaviors is causing, what was like the execution chain of these kinds of attacks. So I'm going to swap back to the demo machine here. And this time, what I'm going to do is take a look at the event log, where we see, so we ran it, so the first time that I ran it, my machine was actually in audit mode. So I had visibility into what was going on. And so we see here that there's a whole slew of different kinds of events that fired from me running that script file, that happened from me running the Word file. And I'm going to go and actually enable these different rules in block mode. So we see here there's a couple of different rule GUIDs, each of which corresponds to one of these different rules. Some of them fired multiple times, etc. So I'm going to set local group policy on my machine to go and actually block this. I'm going to turn on these rules that were in audit mode. I'm going to convert them into blocks. So to block Office apps from creating executable content. That's what happened when I ran the Word file. And then I'm also going to turn on this mitigation here to block executable content being ran from email clients in webmail. So I'm going to go and actually run this script now. And now I'm going to go try and rerun those same scenarios that I did before. And we're going to take a look at what happens. So I'm going to quickly go and reset the demo folder over here and close this Word file. And so now we're going to reopen them. We imagine we just went and kind of got this Word document through email, through a flash drive, onto my machine. And now I'm going to go run this. Has to open, and I have to go and actually, so not going to have to re-enable the macro because kind of I already accepted that. And instead of actually going and encrypting it, we see this pop-up on the bottom right. Your IT administrator caused Windows Defender Security Center to block this action. And kind of those text pop-ups that we see are fully configurable by you guys. You can use the Defender Security Center customization to add your name, your email, whatever text you want, what link they go to when they click on it. And so kind of now you've turned on this mitigation and actually blocked this macro file that downloaded somewhere from the internet that had these malicious processes from going and executing. And so I'm also going to show the example with the webmail, where last time I was able to go and actually run this script file and that I downloaded in a zip and encrypt that same drive. So now as I go and open this, we see the same thing happens. It detected that there was this thing that was going to compromise our machine, actually blocked from this Outlook endpoint. It can also be Gmail or webmail, et cetera. It's any of these different mitigations that, or from any of these different vectors. So now I'm actually going to go swap back to the PowerPoint and continue on and tell you a little bit more about that. So one of the interesting part about this is we're blocking these malicious behaviors, which means that we have the capability of stopping 0 days and new exploits. It's not necessarily about finding a threat that's already out and known. It's stopping something that we haven't seen yet, and kind of it's using this behavior to compromise it. So this is something we just published recently. There was a CVE on an Office 0 day that had this Word macro file that went and attacked the SOAP protocol in a .NET class. And if the attack surface reduction rules are on, they would actually go and block that CVE from ever being able to go and execute and compromise your machine. So kind of enabling all of these rules provides you this level of security that's just blocking all of these different channels through which the malware can go and get onto your machine. So continuing on to the next feature that we have here, which is controlled folder access. And controlled folder access is a feature kind of primarily targeted at ransomware, which is something that has just absolutely been dominating the security news. And so this feature is available on all SKUs, Home, Pro, Enterprise. The previous and attack surface reduction rules are on Pro and Enterprise only. So this controlled folder access is this thing that's been ransomware has been dominating security headlines, and it's an absolute nightmare for you guys. Your business gets absolutely disrupted. Being the victim of one of these attacks causes massive reputation damage. You lose access to your important data. You're in need of dealing with these encryption keys, and you're kind of stressing out over Bitcoin. So I'm going to do a quick kind of summary of these ransomware attacks where you end up getting it onto your machine. This is kind of, we've passed that first line of defense, and something's already on your machine, and it goes and encrypts your data. And then it tells you, hey, it asks you, hey, pay me some money in the promise of giving it back. So the only thing that you have to do in that spot is either A, recover, or go and actually send payment to this user. And then they'll say, and then to actually fully revert that, they'll give you these decryption keys that are promised upon the receipt of funds, which is never a guarantee. And so some interesting things about these attacks is that they are extremely anonymous. They obfuscate their location ownership of their C2 servers, their payment infrastructure. They're kind of wanted to stay alive and continue operating for as long as possible. And also, they're rapidly changing. They're constantly trying new vectors of attack, constantly trying to get onto your machine in some way and cause this damage. And they're also changing the underlying code for evasion and kind of staying ahead of the different mitigations that are in place. And also extremely damaging. Once compromised, you have to pay pretty large sums of money, and you experience data loss after paying the ransom. So So I want to talk a little bit about kind of this rapidly changing thing. So here's kind of a normalized graph of this ransomware, which is called Locky, which is targets a single machine, doesn't spread laterally. And if we look at this time scale, it goes over a single year. And over that time, we see a bunch of different spikes, which are kind of pulses of they go and they are sending out a wave of it, hitting people, compromising them, and then taking a step back and kind of changing some things up and going. So as we walk along kind of this timeline, we see it starts off without having any obfuscation. Then it's starting to hash its registry entries. You're getting this code is being obfuscated, changes up the config format. It's changing up the config, encrypting the C2. The C2 is now encrypted and encoded a couple of months after it started off. It changes up the file extension that it uses. And then at the end, it's kind of changing the file extension again, swapping the different DLLs that it's using. And so kind of the key point here is that they're constantly tweaking and adjusting this strain of malware, and it's for evasion. The authors know we're onto them. It's kind of an adversarial context, and what they're trying to do is they're trying to get around all of these different mitigations that various security companies put into place to block them from getting onto the machine, picking up the kind of the signature to detect that particular sample, but they're constantly adapting. And mitigation is pretty hard against these kinds of things. Whitelisting is a complex thing. You kind of have this loss of productivity around trying to deal with that. You have to make sure all of your applications are constantly updated and there's no exploits that they can go use. Because it takes one thing to go wrong and actually go and attack it. And like there's these great mitigations that we have with attack surface reduction to prevent a lot of those vectors from happening, but there's still mitigations that you have within your actual applications. And then also just the backup and recovery story is challenging, making sure that you can always get back to a good state in the first place. And then finally, user training has some dubious outcomes, which means that the end user is always kind of the victim, is one of the people who is responsible for clicking on the wrong thing or going to the wrong site, or one of the devices is not the thing, or one of your machines isn't fully patched and it just gets compromised. So what we want to do is we want to take a step back and just protect your customer data from unauthorized access. We assume that that first line of defense is going to fail at some point. And so what we did is we introduced this feature, controlled folder access, which takes a simplified approach to protecting your data by starting off with just protecting this known set of default folders. Your documents, your videos, your pictures, your photos. And then we kind of have smart application whitelisting. So on every single process that's tried to access one of these protected folders, we kind of have an ACL check. And we try and determine using all of our reputation on, is it friendly, is it trusted, do we believe the person who signed that particular process? And when it passes that check, it's totally allowed to go and modify and delete content. No issue there. But if it isn't, if it doesn't pass, if it's something that we haven't seen before that is kind of signed and looks a little sketchy, you actually get this access denied, and it's just not allowed to go and access and modify and or delete your data. And so this is kind of designed to be highly compatible. It's just we turn it on, it protects this data in a very broad manner from a bunch of untrusted stuff, and whenever you're, if there are use cases that you have to access that data by something that isn't trusted, there's a lot of different workarounds. It's not going to go and crash your application. You can kind of edit that data in a different place, or, as I'll show you in the next slide, you can add that to the whitelist. And so this feature is designed to just slow down ransomware. These new things that head onto the machine and try and read it, like we've all kind of Petya, WannaCry, et cetera, as those things would be blocked from actually going and writing to and encrypting your data. And so kind of these additional configuration options outside of the stuff that we have out of the gate is this capability to add additional allowed applications. Kind of your line of business app that you use a lot that for some reason isn't trusted yet by Microsoft. You can go and actually add that app to controlled folder access. It goes in, this thing respects AV exclusions as well. And then additionally, you kind of have monitored folders that the default monitored ones, but you can also customize what you want to protect. You can add this OneDrive thing that's mapped to you, or you kind of have your custom location on your machine that you want to go and protect. And so these are all configurations that you can do, and I'm going to show you how controlled folder access works in practice. So swapping back to this machine over here. Oh, wrong one. Cool. So I'm going to go and actually disable the attack surface reduction rules that I set up before to not block the samples from running. Oh, sorry about that, typoing a little. And so here in the Security Center, we go into the virus and threat protection category. And within virus and threat protection settings, we see that we have this feature called controlled folder access. So I'm going to go ahead and enable this. And within here, kind of I get the option to add additional protected folders, as well as add an app to be kind of on this whitelist. And so I'm going to go into protected folders, and we'll see down here that we have a whole list of documents, pictures, videos, music, et cetera, that's protected straight out of the gate. So any of my files that are in there, I wouldn't need to do anything to actually go ahead and protect them. So in our example, I was using the C/demos folder. So I'm going to go ahead and add that to my protected folder list. And so last time we ran it without attack surface reduction rules. Yeah. So you can map the OneDrive folder down to, if it's mapped to C/user/OneDrive or something like that, you can go and add that, and it would protect any process from your machine going and actually writing to that area. It's just whatever's on the file system, you can go and add here, and as we do this ACL check on all these processes that are trying to write there or modify that, if it doesn't succeed, it won't be able to go and do that. So I added the C/demo folders to here, and then I'm going to go ahead and actually run this same file that we used before. So this ransomware test file, which would go ahead and it shouldn't go and encrypt my demo folder because I have no attack surface reduction mitigations in place. We'll kind of go and see what happens. Word, the longest part of this is letting Word go and boot up fully. And so kind of all it really took me is just, I know that I have an area that I have protected data. And I didn't want that to go get damaged, encrypted. And so I added that to this protected folders area. And now anything that goes and tries to access that won't actually be able to do that. So this document here ran. And so it might not have actually executed the macro. One sec here. So I'm just going to use this encrypt decrypt tool that I'd used to reset the mitigation. So I'm running it now. And didn't do anything, didn't crash, and should see a controlled folder access block from making this encrypt executable that isn't some untrusted thing that we haven't seen before, from making changes to this folder. And so before I kind of finish up with controlled folder access, I actually want to go and dive in a little bit into that ATP experience that we had talked about. So I'm going to go and refresh this portal here, which is kind of linked to my particular machine that I've been using for this demo, and we'll see kind of those events, the audit, the block that happened, actually surface up and flow into here, and we can kind of dive in a little bit as to exactly what happened, what triggered what. So kind of there's downloading detecting some malware, and so kind of here, for example, is this example, or 10 minutes ago, of an unknown process was blocked from executing an email attachment from the zip file, and it went and got dropped into this particular area and tried to execute. And we can see like over this time history how these events were actually blocked, and that's awesome. You're stopping threats, you're understanding that this is providing value, that there are these things that I wouldn't want to have happen. But I also want to just call out also the importance of the kind of audit style of events as well, where you don't actually have to block anything, you just get optics into what was going on these different machines, and you can kind of go and investigate them. So yeah.
Quick question. It looks like on your screen there, it does allow you to drill down to the user.
Yeah.
So if you have multiple users on the machine, it'll tell you who was logged in at that time?
Yeah, so you kind of get which of the accounts actually went and ran that. And so you can also kind of go and see this executable. I can dive into it and do some actions as well, such as like ban that hash from all of my different machines and trigger all of the different remediation workflows that ATP has. And yeah, so kind of this thing, all of these events and mitigations that you have go and flow into this kind of a view, as well as being emitted into the event logs and kind of surface this pop-up on your machines. So I'm going to swap back over to the demo machine and hand that off to Jimmy.
Sweet. All right. Thank you, Misha. So Misha just talked you through how controlled folder access and attack surface reduction can help protect you from office-based macros, downloading malicious files, from ransomware executing on your machine, and much, much more. I'm going to dive a bit into, we're going to switch gears a bit and talk about network protection, which is another feature in Windows Defender Exploit Guard. So to sort of get us all on the same page here, I'm going to dive a bit into the threat overview and talk a bit about the threat landscape that we're dealing with here today. So the key kind of point to make here is that the internet is a dangerous place. And if you've ever been on the internet, like if you've ever used an email client or gone on the web, you've probably seen something like this. Phishing attack, people trying to get you to download malware, scams of any sort, like you've won a free iPhone, or your computer's infected, like call us and get it fixed. Or you've seen sites that host exploits that try to take over your machine. So how we want to do, well, another point about that is that end users are the weakest link in the kill chain. And what I mean by that is you can do all you want to secure your machine, but if these social engineers, these attackers try to trick your users into doing certain actions, they're still going to succeed. And another point about that is that bad guys are highly motivated. Like these folks can make a lot of money from stealing your account and from tricking you into giving away information. They can scale massively through ad campaigns and through email spam attacks, and they're highly adaptable. So we can target and fix a certain type of attack, but they can go and make a simple code change or messaging change that will completely change how the attack works. And the end result is that bad guys convince employees to share their work password and compromise their credentials. They convince people to download malware onto their work device, which eventually gets onto your network potentially, and convinces them to run exploit kits, which is kind of the same idea and what some of Misha was showing you. So the solution and the intuition here is, I think, fairly straightforward, is that all of these threats have one thing in common, which is that they can be stopped by killing the outbound connection. So when you're on your host device and the internet is up here and you're trying to communicate with it, we can actually take a look at all these connections being made and what the end destination is, and based on that, kill the connection. And to be more concrete, what that means is that for network protection, we're taking Windows Defender Smart Screen's industry-leading protection in the phishing and malware space, as well as exploits, and we're making it available to all browsers and processes. Today, we have Windows Smart Screen and Edge, where it does pretty well in the phishing and malware space, but most employees and most enterprises don't limit people to just using Edge. A lot of people use Chrome and Opera and Firefox, and furthermore, browsers aren't the only thing that communicate with the internet. Some arbitrary application like or maybe even like a macro like Misha was showing can actually try to talk to the internet as well. So what we do is we take this reputation that we apply to certain sites on whether they're safe or not, and we bring it down level. So I'll show you a bit of technically how we accomplish this. We've shipped a Windows driver, so this is a natively enabled feature in your Windows operating system. Like attack surface reduction is available in the Pro and Enterprise SKUs. And what we do is we examine all the outgoing connections coming from your device. So everything on your actual network stack, so basically everything from your device we're going to take a look at, and we're specifically targeting HTTP and HTTPS. And we're going to go check the URL reputation in the cloud. So an important point to make here is that you don't actually have to configure anything. You just have to turn this on. Like you don't have to set your own blacklist or whitelist. You can just rely on Microsoft's intelligence to tell you whether this thing is safe or not. And we also cache all of this for performance. So this is all on your local cache, on your local device for fast lookup, which means we're not making like a separate network call every single time your device tries to make a connection, which is pretty often. And our service on Windows is capable of updating this local cache as well and of checking the URL reputation against there. And simply put, if it has negative reputation, if we think there's phishing or malware or something else on there, we're going to block that connection completely. So interesting thing people usually ask us about is how this reputation actually works and how we build this reputation. Because for this feature to actually work, you have to be able to trust our blacklist approach of, okay, we know which sites are unsafe. And the way we do that is we have smart screen enabled on most devices. Something like 92% or 98% of all devices have smart screen actually on. So we're looking at about 500 million devices of people who are browsing the web. That's our daily active user count, approximately, through Edge, Internet Explorer, and Windows. And all of these devices are constantly calling Microsoft's reputation service to do a lookup. So when you're browsing to like some site, whether you're just an Edge or an IE, using the internet or opening something from your email address, we're checking that reputation. That happens about 9.4 billion times a day. And furthermore, we send telemetry on stuff that we don't look at yet. So like this is stuff that's fresh, that's new, that's like maybe on the tail end of the web with less traffic. And we're getting visibility into that tail end of the web of stuff that's popping up every single day through our telemetry service. Couple that with some external data, and we tie all of that into our back-end machine learning intelligence systems. So we run a series of heuristics and algorithms in this intelligence system, and that's going to be based on the reputation call that you see, as well as on the telemetry data and the external data. And we train those models. We generate this blacklist, essentially, and we deliver that to our front-end reputation service client. I'm not going to talk too much about this, but couple that on with some business protection layers to stop us from doing something crazy like blocking LinkedIn.com or something like that. And some human grading as well to look at some new sites and to make a determination. That results in the final reputation list that's being delivered to your client. I'm going to just talk through these really quickly. This is some of the, these are results from last year for phishing protection. Microsoft Edge does really well in these. We tend to do better than our competitors. And the same goes for socially engineered malware. So you can trust the intelligence that's being delivered to your device. And I'm about to get ready to do some demos. So to kind of recap what I just talked about, the main class of thing we're trying to protect your device from threats on the internet, basically. And like one of the main classes is that phishing and malware protection through the browser. So when you're in Chrome or you're in Firefox, now you're going to get protection from usernames and passwords being given to the attackers. And we're also going to look at another class of threats, which is the sort of command and control model. What you saw of Misha's demo was there's some malicious file, right, on your device. And it's going to call home to some command and control center. That's some malicious IP or domain. And from there, it's going to get some payload of something even worse, something like a ransomware executable that's going to download and execute. So what we want to do is block that outgoing connection as well. And I'm going to show you that one right now. So switch over here. All right, so we're in that same inbox, and I get an email telling me that my account is past due and that I need to go do something to resolve this. So I'm going to do the same thing that Misha did. I'm going to download this file. And actually, before I execute that, I want to show you that this actually works. I'm going to go here and turn on network protection. All right. So let's try this again. When I try to run this file, so let's say I download this and I save it and open it, enable editing, enable content. And you can see here that before anything even happened, we actually blocked that outgoing connection. So what we did was we looked for that call to the command and control service to go and get that ransomware payload, and we just killed that connection. So it didn't even get a chance to go and try and download this stuff and run it. And I'm going to dive into my next demo here, actually, which is I talked a bit about how we're going to bring into Chrome and Firefox and all these other applications. So I'm going to show that actually working. You'll notice I'm logged in here on Chrome, and I have my emails here, and it says, hello, someone has hacked your Outlook account. Pretty scary. Click here to reset your password. So if I had gone ahead and done that, I would have compromised my credentials. But I'm going to click here, and because I have network protection on, we're going to just block that even though I'm in Chrome using smart screen intelligence. So I talked a bit about, let me switch back to my slides here. So I talked a bit about all the different threat categories that you see and what network protection can do to sort of prevent that just by killing that network connection. And let's talk briefly about the advantages. You saw already from Misha's demo, like it's very easily configurable. You can turn it on with a single switch. It's simple. It's baked into Windows as a native feature. You don't need to do any sort of proxy-based solutions necessarily. You can just turn it on. It's mobile. It works on your host device, so it works even when the end user is corporate network. Like if you take your device to Starbucks or bring it back home, you're not VPN'd in, this thing is still going to work. And lastly, it's powerful. Uses SmartScreen's best-in-class protection in all browsers and applications. So with that, I'm going to pass it on to Nate here to talk a bit about exploit protection.
Great. Thanks. So just a quick recap. We started with Misha telling you guys all about attack surface reduction and controlled folder access. Just now, Jimmy went through the network protection stuff. So I'm Nate, and here to close it out with the last of the 4 components of Exploit Guard, namely exploit protection. So I want to start by just doing a quick straw poll. Could I get a show of hands if anyone here has heard of Emmet or has used Emmet in any context? Awesome, thanks. So Emmet was created in like 2009, and it offered users a way to configure mitigations really easily. It had a great user interface and allowed legacy apps to gain exploit protections that they otherwise wouldn't be able to take advantage of. And we have been really happy with a lot of the accomplishments that Emmet has helped out with. There have been 0 days that specific tactical mitigations have helped prevent. But you know, we've been talking to our customers who use Emmet, and the question kept coming up, why doesn't this exist natively in the OS? And so with the Fall Creators Update, for the first time, we're really excited and proud to show you an Emmet-like solution that's natively in the OS and available on all desktop SKUs. So the UI that we're showing here is the Security Center. And you guys have seen a little bit of this already. We tried to take the best lessons that we heard from Emmet use cases, and we wanted to bring in those default protections into the OS while also giving Windows users a way to configure system-level settings and application-level settings. So what does exploit protection give you? It gives value along the same lines that Emmet provided for Emmet users. It allows you to reduce memory vulnerabilities and exploits that take advantage of them. Many attacks may take advantage of techniques like buffer overflows or use after free, and more advanced techniques like process hollowing as well. Some of these mitigations can help mitigate the impact of those attacks. We also have mitigations in exploit protection that restrict processes from accessing particular critical APIs and low-level functions, things that are really dangerous and give the process a lot of power to mess with the kernel or to mess with the system. We want to guard against API hijacking and elevation of privilege style attacks as much as possible using those particular mitigations. And the third item here is to protect legacy applications. This was the biggest pain point we heard from the surveys we did and the research we did into Emmet use cases, and we realized that in a lot of cases, legacy apps don't get recompiled very often by the ISV, and a lot of these apps are fairly old and don't have a lot of the compile time protections that modern apps do. Before, you could use Emmet to turn on certain ROP mitigations to help mitigate return-oriented programming-based attacks, and now these same ROP mitigations are part of Windows. We wanted to make sure exploit protection was easy to use. So in addition to integrating it with the Security Center and supporting SCCM and MDM for manageability, we also provided a process mitigations PowerShell module designed particularly for existing Emmet users. So anyone with Emmet deployed today who has customized particular settings to protect their apps, they can use our PowerShell commands to translate that into exploit protection settings and then subsequently apply those so that Emmet customers can get the same customized settings immediately on Fall Creators Update machines. And we also want to point out that Misha already spoke to this a little earlier, but the event viewer does track both audit and enforcement mode. So even if the mitigations are turned on not to actually block things from happening, we'll still be able to see some events in the event log. So we are introducing some brand new mitigations for the first time with this release. Some of these may sound familiar to you if you've used Emmet, and they are now integrated in to the process settings part of exploit protection in the WDSC. And I'll show you guys that in a bit. But the next slide here, I wanted to give a little bit of a warning. It's got a lot of text on it. But this is all of the mitigations that exploit protection includes. And I won't bore you by diving into the details for these, but rather draw your attention to a particularly useful example. There's a protection called control flow guard, which ensures the integrity of a process's indirect calls. But the way that CFG knows that an indirect call is valid is by referring to a bitmap that's created at compile time. So if an application was not compiled to take advantage of control flow guard, they're at a bit of a loss for this protection. But we have 3 RUP-style mitigations that can be forced on for even these legacy apps. So we would recommend business apps that don't have CFG protection to, for example, turn on symexec, caller check, and stack pivot, which all sort of inspect memory of the stack and the heap and try to detect signs that a ROP attack is occurring. And lastly, a lot of these mitigations were already in Windows for many releases and were turned on by default, kind of just ran silently in the background. But this is the first time we're giving really a way to get detailed into customizing those protections. And really quickly here, there's not too much to say about this technical slide, but I wanted to point out that the teal oval in the bottom left, app.exe hits mitigation, it's here showing that in addition to writing to the event log, when a mitigation is tripped, we also send data to the ATP portal. And doing this, we can gain more confidence in our recommended settings. So a bunch of the mitigations are already turned on for the system or for particular processes based on our own research, our own analysis. But with real users and the telemetry we get from real users, we can expand the recommended settings list so that it captures the Windows ecosystem more accurately. And if you guys used the recommended settings for Emmet, we basically looked at that as a template to start with in creating recommended settings and offering them for exploit protection. So jump into a demo really quick. I kind of want to show you just how you would go about actually turning on exploit protection. And like I said, there's a bunch of different mitigations here, but they're all under app and browser control exploit protection settings right here. And so in looking here, we see that there's system settings for CFG, data execution prevention, ASLR, and chop and validate heap integrity. And these are system level settings, the defaults that I was referring to. But we also have program settings. And so to show sort of a demo type example here, I'm going to add a setting for Notepad. And basically, it could be added by path or by exe name. And here we have the program settings. So the particular mitigation I want to turn on is disable Win32K system calls. And basically, the Notepad application needs to use Win32K to paint the display and actually open correctly. But let's say Notepad is a stand-in for a business app that doesn't need to do any of that, and we want to prevent it from accessing potentially dangerous Win32K system calls. All we would need to do is override the system settings and turn it on. And after applying this change, we should see Notepad fail to open. So that's what we expected to see and how a different process might be blocked as well. And so that's just how to configure exploit protection. The final bit here I want to show and share with you guys is a demo video for a real attack. And this is a real CVE from earlier this year on an unpatched version of WinWord. And so I'm going to play through the demo here and skip around in the video a little bit just because there's some stuff that you've already seen, the UI you've already seen, for example. But this exploit actually takes advantage of two different XEs. Oh, let's see. Press what? Mm-hmm. Okay, so I'm going to just click on. So maybe I won't be able to skip around. We'll just play through the video, I guess. All right, so here's the exploit protection menu, which you guys just saw just now. Again, this is an actual CVE that takes advantage of an unpatched WinWord. And we're going to showcase two of our mitigations here, namely disable Win32K, or sorry, namely do not allow child processes and block remote images, which do exactly what they sound like. So there are two XEs that this attack takes advantage of to conduct its exploit. And here what it is going to do is open calculator. But first off, we're going to look at this XE and configure the do not allow child processes mitigation in audit mode. And so this isn't actually going to prevent our word exploit attack here from creating a child process. The child process it creates will then use a run DLL32.exe to call the run DLL calc, and by loading the remote DLL, thus opening calculator. So the second mitigation that we're configuring here, again, in audit mode, is block remote images. So this would prevent that run DLL32.exe from loading remotely the calc DLL. So now we'll see it in action, but again, the mitigations are configured in audit. We see that when the Word file is opened, that the stage 2 of the attack gets pushed to our Windows folder. You'll see a stage2.vbs pop in there. So the Word file opened, and there it is, stage2.vbs, which then gets executed. A decoy Word document is created right there, and calc.exe was opened, as you guys saw. So here the attack worked successfully, but we should be able to confirm in the audit log that these two mitigations would have prevented the attack from doing its job. Pointing out here in the script that was used, run DLL32, run calc.dll, that's how we know that that's what's going on. But next we're going to open up the event viewer, which you've already seen. Some of the exploit protection mitigations create and write to the user log, and some write to the kernel log. So they're both here under security mitigations. And by clicking on the kernel mode log, we can see a little bit of detail about run DLL32.exe, how it would have been blocked from loading a binary from a remote share. And then another event will tell us that run DLL32 would have been blocked from creating a child process. And wscript.exe would have been blocked from creating a child process. So now that we know that our mitigations would have caught these attack styles if they were turned on in enforcement mode, we can go ahead and actually do that to show that the behavior will be blocked. So now we're going back into the Security Center and turning off audit settings for both of the mitigations we talked about previously, about creating child processes and loading remote images. And after we do that, we actually only turned on one of the mitigations in enforcement mode. So that'll be the one that actually stops the exploit for this example in the video. The other one is still running in audit mode. So here the exploit file is clicked and the attacker begins. The stage 2 script is created on the disk. But this time there was a problem starting run calc.dll. And that's because we had changed block remote images from audit to enforce. And so we see that even though the decoy Word file was created, calc did not open, and our underlying data and potentially sensitive files are okay and safe. The events, again, are still created even when the mitigations are set to block, to enforcement. And yeah, that is the end of the demo video. So just to kind of sum up, we have some resources here to share with you, and you guys can dig in more later. But we have a lot of time extra here for questions.
Yeah, so one other, can I get the mic on real quick? Yeah, so one other interesting thing to note is that like the exploit guard capabilities are kind of being rolled out as part of like the security baseline, and just there's things that kind of we're providing a default XML for exploit protection that kind of goes and sets this baseline for how you should actually go and configure it, and as well as for some of these different attack surface reduction and network protection capabilities to be on in block mode and actually just take off and cut this vector through that which malware can get onto your machine. And so kind of there's also a bunch of other related sessions on topics that we floated around. There's some sessions that have happened over the past couple of days on the Windows Defender antivirus, on ATP, and then there's some other ones coming up on kind of more in-depth on ransomware, a little bit more in-depth on actually going and configuring using Intune and SSCM, all of these different capabilities, and kind of more a little bit on like this investigative approach on how we go and come up with the malware and exploits that are going on and how we actually go and stop them. Yeah, so we kind of have finished up a little bit early, so feel free to kind of hit us up with questions. We'll come up to the mic.
I think, yeah, they wanted you guys to use the mics so that it gets on the recording. Thanks.
Yeah, go ahead.
So I guess the recommended way to go with this is using audit mode first. How do you collect this knowledge when it's audited and in event logs locally?
Yes, so all of the event log, so you turn it on in audit mode and you kind of let it run on your machines in your enterprise, make sure that there's no like compat issues with your line of business app. And so all of them kind of go and surface into the event log, and you can go and actually look through and collect them. Or if you kind of have the ATP console, you can go and actually view which of these things are firing. So it's kind of audit has the same transparency, the same way that you would see, oh, did something actually get blocked? But it doesn't actually enforce it. It just gives you optics and allows you to see what would have happened. And we have that for all of the different capabilities within Exploit Guard.
With exploit protection, is this going to be a one-for-one mapping with capabilities we had in Emmet?
No, it's not one-to-one.
Are there capabilities that will not be supported in Exploit Guard?
All of the capabilities are in Windows, but not all of them fall under Exploit Guard.
Okay.
If there's a particular one, I'm happy to speak to it that you're considering.
DEP, ASLR.
Those are in exploit protection, yeah.
Okay, kind of as a follow-on to that, is there a mechanism for opt-in or opt-out for applications that might not work with these protections turned on?
Yeah, so the ones that support system settings have levels of setting where it's app opt-in or app opt-out.
So if we could do it with Emmet, we can do it with exploit protection?
Yeah, modulo the parts that don't correspond to exploit protection, which is kind of a nitpick, but yes, all of the main flows are in exploit protection for Emmet protections.
Okay, thank you.
Yep.
It's a quick question. Is there any guidance for third-party products integration?
So exploit protection will work with kind of any third-party AV on it. For attack surface reduction, controlled folder access, and network protection, all of those are kind of tied into the Windows Defender engine that we have that powers our AV. So kind of that's a requirement for using those that you're using the Windows Defender antivirus. And those like three components that we talked about, the AV, 3 of the 4 capabilities of Exploit Guard, and ATP kind of are compose like that protection stack, along with some of the capabilities that we have. Attack surface reduction, network protection, and controlled folder access. So the first 3 that we talked about use the Windows Defender AV to actually power those kind of intelligent and smart rules and able to block behaviors as opposed to just blocking like an individual file.
Is this designed to replace other head or hip systems such as Carbon Black?
Yeah, so you kind of have we don't have all of the capabilities of like going and turning on individual rules. Our kind of approach has been to go and provide a bunch of these control points and have these intelligent rules that go and actually block and stop these vectors from going on and actually being able to execute. as well as kind of moving forward, we're adding a lot more different rules and capabilities. Within the attack surface reduction, there was just a bunch of rule goods, which is what we shipped in this like V1 version of this product. And we're continuously tuning the models, making them cover as new ransomware attacks come in, adapting, and then also adding additional capabilities moving forward.
And are you going to support other OSs such as Mac OS and Linux?
So we don't support other OSs. We're just running on Windows.
Is there any future to create like an agent that can be deployed to those systems?
There we have some kind of, there's some ATP integration where like you can still use that console single pane of glass experience to manage other devices. But as far as like the Windows Defender antivirus and exploit guard, those are just for Windows.
Okay, thanks.
Yep. Go ahead.
That exploit error code that pops up, that may be obvious to security team, but maybe not the desktop teams. Is there any way to edit what it's saying in there?
Yes.
All it said was access denied.
Yes, so I think I mentioned this at some point, but like all of the Windows Security Center text that pops up is fully customizable by kind of the enterprise experience. So it's just policy that you push down that says, this is my name, this is what the text should be, this is, if you like click on this link, here's where you should go into kind of your help page or support page and kind of redirect people where you want to go. So that text box is customizable from the Security Center policy.
Great, thanks.
Yep.
So you mentioned that all of these are available in both Pro and Enterprise SKUs. However, some of the reporting looked to be in the WD ATP portal. Do you need a Win 10 Enterprise E5 or M365 E5 to get that reporting?
Yeah, so all of the capabilities come straight out of the box within Win 10 and just on Pro and Enterprise SKUs, and kind of to utilize the monitoring and reporting within the ATP that does require that E5 license. So kind of all of the capabilities are there and you can turn them on, and if you use kind of a different, kind of to separate the two of the raw capability with what you're using for monitoring and reporting, that part is E5 and kind of the other capabilities are available otherwise. Awesome. Sweet. Yeah, one more question.
One of the questions I've had about a lot of these security tools is, can they be used strictly on-prem, or are there cloud components that need to be enabled? Can telemetry be turned off on some of these?
Yeah, that's an awesome question. So for exploit protection, attack surface reduction, and controlled folder access, you can actually run them on-prem with telemetry turned off. A lot of the kind of the learning and new features and capabilities come in through the traditional update channel. So as long as you can get Windows Defender AV updates, you'll also be getting those capabilities, and they don't require any online connection to actually go and function and run. So you go have these attack surface reduction macros turned on-prem, and they'll actually go and block any Word file. The network protection component, however, does kind of have this outbound connection to go check our cloud, and that's not available on-prem. So the network protection component won't work without that outbound connection, yeah.
Thank you, that's great news.
Yep, awesome.
Hi.
Hi.
I've seen something on the slides regarding blocking API hijacking. How does that actually work?
So two of the mitigations, EAF/EAF+ and IAF, are about filtering access to import and export address tables, so that not anyone can just access the table and resolve a procedure that we know is low level, critical, et cetera.
Awesome. Sweet. If there aren't any more questions, going to end the session a little. Oh, one more, sorry. Go ahead.
One more question. Let's say you have enabled the application control and the smart screen. Which one would actually be the first one to scan or something like that?
I would say that's probably threat specific. So like if the first thing it does is try to make an outbound connection, like if it's some executable, then we would catch it. But were you talking about application control like the folder guard thing, or?
So kind of the application whitelisting style stuff? Yeah, so kind of if something within application control that's going and running and actually making it. So application control allows which applications will go and actually execute. Kind of the outbound call would get blocked by network protection, for example, or if that application is exhibiting any suspicious behaviors, that would get picked up by attack surface reduction, or even if an application that is under whitelisting is trying to access a protected folder, it would, because it's kind of, so that integration that we're moving forward is kind of putting all of those whitelisting sources into kind of one ground source of truth. So kind of ideally, yeah, is application that you say you trust with application control would be able to go and access your protected folders. Yeah.
Thank you.
Sweet. Awesome. Thank you, guys.
Thank you.